lecture, we are discussing. So in the today's class, we will discuss the next possible step in the database design, which is how to map ER diagram into equivalent logical schema, right? So from today onwards, whenever we refer the database, it is always by using this concept or this representation called logical schema, right? Uh, in the previous lectures, we have discussed the different steps of creating the conceptual schema of a given data requirement, right? So basically, this conceptual schema gives an idea about the different elements of data requirements which has been given to the person, and primarily it has all these requirements are mapped into some visual diagram or some kind of modeling, right? So we refer this instance of the database design or database perception as a conceptual data model or maybe conceptual representation of the data requirement. Now eventually, because we have to implement all these requirements which we have captured in the form of conceptual data, so we have to have again a representation or maybe equivalent mapping of the requirement which we have captured in the ER diagram. So now we have to map this ER into a representation or into a nomenclature which can be directly mapped, which can be directly created, right? So this purpose of logical schema is to basically create or represent a kind of representation of the same data requirement which we have captured in the ER diagram, and you can take out the details from logical schema and directly create all these. Now I can use the term database tables and their attributes and constraints, right? Because whenever we are at the level of logical schema, it is always there that you will not be having externally relationship mentioned, right? So that's the purpose also. So when we have ER diagram, we have attributes on the entities and the relationship between entities, right? So relationship means there is a relationship between a pair of entity with cardinality degree. But when it comes to logical schema, it will not have this representation. It will be mapped in some way, right? So like in the case of ER diagram, we have defined these relationships and also mentioned their cardinality. But now, because we have deriving this logical schema, there is a mechanism to map these relationships into the logical schema, right? So we will discuss it. Then whenever we are discussing this part, how to map relationship, then there is concept called foreign key will be used, right? Like in the labs, actually, we have already taken the concept foreign key, what is the role of foreign key. But now we will be discussing upon the theoretical background based on which or due to which we are using foreign key concept, right? So primarily we have discussed the conceptual data representation. So conceptual data representation or conceptual data model is the first representation or first design representation of the data requirement. And when we say what is logical schema, logical data model, the logical schema is a it is a another representation of the same data requirement with respect to the actual data creation, right? So this logical data schema is very close to the actual data uh, data data scheme or database which we have to create, right? So that's why I'm saying you can directly read the documents, read the instructions, read the information given in the logical schema, and you can create the database. That is very sure, right? So it is one of the closest representation of the database schemes which we will be going to create, right? And naturally, whenever we are talking about logical schema, it means we have to discuss, we have to perform some mapping between conceptual to logical, right? So it is not abrupt step that you can design a ER diagram and then you can write the logical schema. There is a specific mapping, because each and everything from the logical conceptual schema should be mapped into equivalent concept of logical schema. So it is a very obvious and very simplistic, common sense based approach to map a particular uh, ER diagram into the equivalent logical schema. Now we will see how basically what are the details of this particular logical schema, logical data model will be basically having. So in the most of the textbooks, if you read, they used to have this conceptual slash logical schema. I mean, if you recall the three schema architecture which we have discussed, there basically they have three schemas. First is schema on the top where user is interacting, and then there is a bottom schema where data base storage components has been placed, and in between, in the middle level, this schema is placed, which is referred as conceptual slash logical, right? So I mean, this is written because in the most of the books also it has been referred as a conceptual or logical, something like that, because both representation indicates to the same data requirement, right? It is just that the logical schema is very close to the implementation view of the real database, and conceptual schema is the first representation of the data requirement. So both are basically used for different purpose. They are not the implemented version of the database, but they give you a lot of impression about the possible database which could be designed, which could be created, right? So in the case of logical data schema, you can say basically if you read the relationship between them, it's like a conceptual data model is a good to represent the high level modeling of the data requirements, which we have already discussed, right? And logical data schema, logical data model is a system level representation of these requirements. So whatever requirement we have captured, logical data model gives idea about the possible system level or system compatible or system view of the data requirements. Now with this, you can have a basic idea that this could be one of the type of logical schema. I'm not saying this is the schema we are going to create, but this could be one of the type, one of the representation under logical schema, right? So one of the type of logical schema is the schema which we have given in the labs. So students of CS4 and CXCs can relate. In the very first implementation and the very first lab experiments, we have given these schemas, right? We have given 4 databases. Under each database, we have listed 3 or 4 database tables with their respective attributes, constraints, and possibly foreign key also. So that is also one way of writing the logical schema. In more detailed way, you can write the same logical schema into a form which is shown in this diagram. You can see. So this could be one of the database where we have these 5 different database tables or entities like address, order, item order, customer, and items, right? Something like that. And between each pair of entities, each pair of basically tables, you can say right now, there is the relationship defined with its respective cardinality. Within each database table, there are some attributes. Their data type has been given. If constraint is imposed, it is also given. So this is one way of writing the logical schema, right? So once you draw the ER diagram, you can derive immediately this representation of the database. And if you share or give this representation to a person who is creating the database, he can easily understand that what could be the attributes, what could be the constraint, what could be the relationship cardinality, right? Based on which or due to which this foreign key has been created. So this will give a exact, precise, and sufficient information to the database designer or maybe DBA, which will be going to create this particular database, right? So basically, logical schema represents the entities and other elements in the way that will be created in the system. So basically, you need to create this to understand the all possible details, and eventually you are going to share it with the next person who is going to create this database, right? That's the only purpose, right? Now, going further, I mean, it is a important step. It is an important outcome to have. With respect to exams also, whenever in exams we used to ask question, okay, can you design the ER diagram of the scenario? The next question could be like, can you derive the logical schema also? Can you derive the equivalent logical schema? So after design the ER diagram, there could be next question which says or which asked, okay, can you design or can you create the possible logical schema of the given data scenario, right? So that's why it is important to have this idea that first I have to draw the ER diagram, next I have to create the this logical schema of the given or of the created ER diagram. right? So this is kind of compulsion to derive ER diagram and logical schema for a given requirement. Now let's understand how to map ER diagram into logical schema. So there are specific steps, I can say steps, or maybe some sort of process or some sort of procedures defined to map ER diagram into the logical schema. So we will read one by one. So primarily, I mean, you can take out this obvious, idea that uh, in ER diagram we have created a lot of, a lot of entities and their attributes, respective attributes, like primary key attribute. Then there we have multi-valued. Then we have derived attribute, something like that. And between the pair of entities, we have defined these relationships. So the first thing which you should have in your mind whenever you are mapping conceptual schema to logic schema, it is the possible database tables, right? So that's why the first obvious step is to identify or to define the possible database tables which could be possible, which could be required to map the ER diagram, right? So let's see how things will be going to happen. So in the very first phase or in the very first stage, we will see all the possible cases, all the possible reasons due to which a database table will be required or could be created in the logical schema. So if you recall the ER diagram which we have drawn, now the very first rule say you have to create a database table for an entity. So each entity will be having one equivalent database table, right? So each database, I mean, each ERD entity will have its equivalent database table. So suppose in an ER diagram we have four entities defined. It means in the logical schema we will have at least these four database tables. That is for sure, right? And we refer these entities as a, base entities. So whatever table we will be deriving, it will become a base tables, right? So you can read how here also for each entity with the located attributes, you will have a database table. And naturally, when we will be mapping this one entity to its equivalent table, all the attributes also will be defined in this particular database table, and along with naturally the primary key thing. And whenever we are writing the logical schema, the primary key attribute should be underlined. You can write it underlined, like roll number underline, something like that, right? So that is the first step. That is the first obvious step. Now there are two typical cases due to which we have to create additional tables. Additional tables means we will have four database table for four different entities. But among this, in this ER diagram where we have four possible entities, there could be possibility of, due to which or for which you need to create these some one or two additional database tables. So the first reason is the multi-valued attribute. Like we have observed, in one entity, there are some attributes possible which could have multiple values like address, contact number, or maybe email ID, right? Something like that. So if in an entity, I am talking about in an entity, if in an entity, attribute which is of multi-valued is placed, is designed, in that case, you have to create a new database table in the logical schema. So along with these four base tables, now you have to create the fifth one also, because there is one multi-valued attribute in one of the entity. And it is also possible that in the same entity, there is another multi-valued. So you have to create the sixth one, sixth table. So I'm saying for each multi-valued attribute on an entity, you have to create a separate database table in the logical schema, right? That is first thing. Second thing, naturally, we are creating a separate database table. So the primary key attribute for this separate table due to the multi-valued attribute will be the combination of the multi-valued attribute and the primary key of the base entity, primary key of the base table where this attribute was placed primarily, right? Initially, this attribute was defined in entity E1. Now we have observe that we are mapping the ER diagram into the logical schema. So to take care of this multi-valued attribute, we have created a new database table where we are placing the primary key of the entity, main entity, and this multi-valued attribute also. So only two attributes, right? So the combination of pk of base entity, primary key of base entity, and multi-valued attribute, we can create the primary key of this new database table, right? And that is the first thing. Second thing, the name of this new table will be the table base table name of the base table, and and attribute name. It will be like attribute name. This multi-valued attribute. Let me precisely type also. Yeah, multi value attribute name, right? So like in the case of one of the diagram which we have discussed, department is having multiple locations, right? So because of that, we need to create a separate table which will be named as a department location. So department is the name of table where entity, where this location attribute was observed as a multi-value. So we have created a new table which is named as department location, and which will have attribute like department number and department location as the primary key, right? So now this multi-valued attribute has been separated from the base table, right? So you should be having clarity. So we will be looking upon a specific example also to understand all these things, right? So that is the first case because of which we need to create one additional database table. Second possible case is Second possible case is because of which we have to create a new database table along with the base tables. So the second case is whenever we have MS to N relationship. So naturally, when I mean in a particular ER diagram, there is a many cases, there is many instances where this MS to N relationship is the possibility. So to take care about the MS to N relationship, we have to create an additional database table, right? So for each instance of MS to N relationship, you have to create an additional database table. And in this database table, the primary key of both entities, so primary key of both entities will become the primary key of this new database table which we are going to create, right? So that is the basically idea, okay, based on which you can create the primary key of the new identified tables. Because for multi-value attribute scenario, for MS2 relation scenario, we have not talked about the attributes of, you know, attributes or maybe the possible primary key of the new possible database table, right? So we have to carefully identify the possible attribute for the newly designed tables, newly identified tables, right? So for multi-valued, it is the primary key of the base table and the multi-valued attribute which will act as a primary key. For MS2N relationship scenario, the primary key will be the primary combination of primary key of both entities, right? So one typical example, if you can recall, we have talked about a data ER diagram where we have observed that between employee and project, there is MS to N relationship, right? One employee could work upon more than one project, and one project will have more than one employee, obviously. So it is MS to N relationship. So due to this MS to N relationship, we have to create a new database table, right? And this new database table will have employee number and project number as a primary key. That's one thing. And you can name that particular database table which we are creating in the names of works on, in the names of relationship name. So in that case, the relationship name which we have defined as MS2N is works on. So you can define or you can give the name of the table which is happening because of MS2N relationship as in the name of relationship, and attributes will be the primary key of both participating entity, and the primary key of this works on will be the combination of these two, something like that, right? So this is the scenario. These are the three only possible reasons, only three possible. There is no other scenario. These are the three reasons which decides the number of possible tables in the logical schema of a conceptual schema or of a ER diagram, right? So that's it. So you can, I mean, you can define a specific thumb rule also by simply having rule also. So whenever a question is raised to you that, okay, suppose in ER diagram there are m number of entities, n number of multi-valued uh, attributes, and three instances of MH to N relationship. So what could be the possible number of database tables in logical schema? So it will be m plus n plus 3, something like that. So these are the total number of database tables we will have in the logical schema, or maybe in the database also. Now, MS to N relationship has been defined and all these things. So, but there are few scenarios which has not been discussed, right? So, because we have not discussed about 1:1 relationship, how it this 1:1, 1:N, N:1 should be captured. I mean, should be modeled, should be mapped into the logical schema. So, there is this concept called foreign key has been used, right? So this concept of foreign key we have partially discussed with the section CS 4 and CS 6, and how it could be created in the database and how it will have effects on the domain of a specific attribute in the child table, right? So that's what we have discussed. And now let's see where it is coming from, right? It is obvious that you should place the foreign key attribute in the child table, and there will be one table which will be acting as a parent table, right? So we will take out, we will identify, use the primary key of child parent table and place into the child table as a foreign key. That's something is a logical schema saying. But there is this theoretical background which says, because of which this foreign key attribute is being identified or being placed, right? So let's see, and it is because of primarily three reasons, primarily three types of relationships, 3 degree of cardinalities. Now, if you see 1:1 instance in the relationship, if you see in the ER diagram anywhere this 1:1 relationship has been defined, you can immediately decide, or you can immediately say that whenever I will be mapping this 1:1 into the logical schema, I will be taking out the primary key of any entity which are participating. So suppose there is this entity called employee and department. So employee and department for the relationship, suppose they are attached or they are related to 1:1 relationship. In that case, you can take out the primary key of employee and place into the department table as a foreign key, right? Or maybe you can take the primary key of department table and place into the employee table to map this particular 1:1 instance of relationship. Because here we are having equal relationship cardinality from both sides. So you can use the primary key of either side of the relationship and define that attribute, that primary key attribute into the other side of entity as a foreign key, because that attribute is coming from the different entity into a local entity as a foreign key attribute to model this relationship, 1:1 relationship, right? So in the case of 1:1, it is quite clear, it is quite simplistic. But in case of 1:M, or in the case of M:1, right? So this is what we have discussed in the labs also, when we place, M side primary key into the one side entity as a foreign key. Second, when we have placed the primary key of one side entity to the M side entity as a foreign key, so what could be the possible repercussions, side effects will have? So primarily it has been observed, if we place the primary key of one side entity, primary key of one side entity to the M side entity as a foreign key, so it will solve the problem. So this is the best possible solution. So suppose there is employee, there is this department, or this uh, department possible. So between employee and department, if relationship is M:1, employee is on M side, so we can place the department primary key. Department is one side entity, so we can take out the primary key of department entity and place it into the M side entity, which is employee, as a foreign key. So here at the employee entity, we will have, or employee table, we will have one additional attribute which will define this relationship called M is to 1, or maybe 1 is to M. So in the case of 1 is to M, M is to 1, you should basically place the primary key of one side entity as a foreign key in the M side entity. This will model this instance of relationship, right? Going further, if you see any instance of MS2N, though we have created a database table for MS2N relationship scenario, right? So once you create additional table for MS2N situation, you will be using the primary key of both participating entity into this database table, and both the combination of both will act as a primary key. That's the thing we have discussed already. But each and every attribute, so like we have placed two primary key attributes in the table, naturally these two individual primary key attributes are also to be defined as a foreign key, right? Because they are coming from a different table. So now if you see, all the details, all the elements of ER diagram are now mapped successfully into this logical schema, right? So let's see, and let's see the same database, the ER diagram of the same database, and we will verify each and every concept which we have just discussed, and see what is the possible equivalent list of database table we could have, right? So in the left side, you can see that this ER diagram which we have taken as a benchmark ER diagram to discuss the details, right? So this diagram, ER diagram, we have taken as a benchmark for the subsequent discussion, or maybe for the remaining discussion in this whole course, right? So this is the database representation, ERD representation of a database of a company scenario, right? So you can see we have employee, department, project, dependent as a entities, right? So it is obviously possible. It is obvious that we will have at least, or at max initially, at least 4 database tables. You can read here. We have defined employee, department, project, and dependent, right? So initially we have defined these 4 basic database tables along with their attributes. So in the employee, if you see, we have placed first name, middle initial, last name, SSN, birth date, address, gender, salary, and these 2 attributes are there, super SSN and D number, which you cannot see in the ER diagram. So if you relate this employee table into an employee entity in the ER diagram, you will not find these 2 attributes, super SSN and D number, right? And these 2 attributes are added for modeling the relationship. Similarly, in the case of department table, you can see department is having department name, department number, MGR SSN, MGR start date. These 2 attributes are not existing in the ER diagram with the entity department. So these 2 attributes are coming into the table because of some reasons, right? Because of some relationship thing. Similarly, if you see the department location, so there is no entity of with the same name. It means it is derived by either multivariate reasons or maybe the MS2N instance. Now, if you see the project table, in the project table we have attributes like project name, project number, location, and this D number thing is there, right? So you can see the D number attribute is being added to model some relationship, right? This foreign key thing which we have just discussed. So we will discuss each and every instance. If you see the works on, again, works on entity is not defined in the ER diagram. It is because of some scenario of multi-valid, or maybe because of MS2N, right? We will see in just a subsequent discussion. Now, if you see the last database table, which is dependent, dependent is a weak entity. As you can see, dependent is drawn as a weak entity, but in the modeling of your diagram to the logical schema, you have to draw, or you have to define a database table for weak entities also. It is just the concern where we are having in the primary key designing, primary key identification. So if you see in the dependent entity, the name is defined as a partial key. That's why it is underlined with the dash lines. In the name attribute, for a weak entity, we have marked as a partial entity. But in the case of database table for dependent, if you can see, this dependent name and ESSN is acting as a primary key, right? So we will see each and every one. So now the very first step is done. We have mapped all the entities into the respective tables. Next step is you have to see for the multivariate scenario. So for department entity, only department entity in this ER diagram is having multi-valued attribute, which is called location, right? And department table is having three attributes: name, number. So department name, department number, and location as a multi-valued attribute. So because of this location as a multi-valued attribute, we have to create a new database table because of this multi-valued attribute, and it should be named as department underscore location. Because what we have decided, in all cases where we have multi-valued, you derive the name as the name of based entity and the name of attributes. That's why it is called department underscore location, right? Now, if you see for the other entities, we don't have any attribute on any entity which is like multi-valued attribute. So we will see for the MS2N relationship, because that's the last reason, or there's the third reason for to be defined as a new relation or maybe new database table. So out of all these relationship instances, there is one instance of relationship between employee and project, which is of MS2N. And for this, we need to create a specific or separate database table, which should be named as the name of the relationship. Like works on is the name of relationship. So we have created a database table named as the works on, and we have placed the primary key of both entities. So for employee, it is SSN, but you can rename it. So it is renamed as ESSN, and the project is having primary key as P number, right? Something like that. It may be incorrectly written in the ER diagram. It is the project number which is acting as a primary key of project. It is not the name, right? So for project entity, the project number is the primary key. Now, whenever we are defining a new database table for works on, we will use the primary key of project and entity, right? So both the combination of ESSN and P number will act as a primary key of this works on table. Now, you can see there is additional column placed hours. So hours is placed in the relationship table because it is the attribute which we have defined as the relationship attribute. We are not certain that which side this attribute should be placed. It should be placed on the project table or it should be placed on the employee, but it will affect the number of additional values to be introduced in the base tables. That's why it is placed under the relationship table. Now, after this, naturally, we have discussed the possible cases because of which the database table to be created. So you can see in the very first instant, or maybe in the third step, you can see these are the only possible table which could we have: employee, department, department, project, works on, dependent. And we have partially defined the primary key and the base attributes for each entities. Now, when it comes to the foreign key aspect, now you have to see the remaining aspect of the ER diagram, which is the relationship cardinality. So let's take one by one, right? So if you see the instance of 1:1, so we have one instance of 1:1 relationship between employee and department, which is because of manages, right? So we'll see there is this cardinality ratio placed as employee manages one department. And when we have this 1:1 instance of the relationship, we can use the primary key of either employee or department number to be placed in either side of the entity. So you can see carefully this ESSN, primarily this SSN, which is a primary key of employee, is placed into the table department as MGRSSN to define this 1:1 relationship, right? That is one instance. Now, for the instance called employee works for department, which is N:1 instance, what we have done, we have simply taken the primary key of department table and placed into the employee table as D number as a foreign key. So in the employee table, this D number is defined as a foreign key, and it is coming from the department table and its D number attribute to map this relationship of an is to one nature called works for. Right? That's done. Now, if you see the employee entity, now employee entity is also have a recursive relationship. You can see a supervision. So it is nature of 1 is to n, right? So we have a recursive relationship where both side we have employee, and this cardinality is 1 is to 1. It means we have to define a attribute as a foreign key on the employee table, which model this relationship. So that's why we have added an additional attribute in the employee table named as super SSN, right? So this super SSN is named as super SSN, but values will be referring to the SSN only, right? So because we have both side employee, so we have taken the primary key of employee, one side employee, and place into the employee table again. So it is like we are having foreign key attribute which is referring to the same table, referring to the same table's primary key, right? And this is the nature of secure recursive relationship. So this super SSN is primarily placed to define this relationship because of supervision, right? Now we are going towards the next part. There is this okay, so there is this attribute in the department which is placed as mgr start date. Now here we can place, in the case of mh2 relationship, you can see this r's attribute is placed on the works on relationship table, but this start date, which is a relation attribute of relationship manages, is placed on the department because we have defined this instance as 1 is to 1. So you can move the relationship attribute in either side of the entity, right? So that's why we have placed as a mgr start date. So it is nothing but it is the date of person who are managing a department, something like that, right? So now if you read further the relationship between department and project, it is 1 is to n, right? And it means we have to take the department number primary key, which is D number, and place it into the project database table as a foreign key. So you can see the project database table, it is said D number. So I mean the table attribute is renamed, but it is referring to the same D number of the department, right? Similarly, if you read this relationship between employee and dependent, so this relationship cardinality is 1 is to n. So what we have done, we have used the primary key of the employee, which is SSN, and place it into the dependent database table as ESSN. Now you can see ESSN is placed here as a foreign key. First thing, it is placed as a foreign key in the first hand, but because dependent table is a weak entity, because of this we have to make this ESSN, which is acting as a primary key, we have to make ESSN and dependent name both as a primary key because dependent is a weak entity, right? But primarily this ESSN is placed because dependent is a foreign key coming from the SSN because of this n is to 1 relationship. And in the second moment, you have to define the primary key of this dependent entity. So we have combined this foreign key attribute, ESSN, and dependent name as a primary key for this database table called dependent, right? That is very short. It should be always so. In the attribute, on the attribute ESSN, we have two constraints. First, it is a foreign key. Second, it is a part of primary key, right? Part of primary key for this database relation, right? Similarly, if you take the last discussion on this, there is this table works on, which is coming because of MS2 and instance relationship. And we have primarily placed ESSN, which is a primary key of employee, P number, which is a primary key of project. So both primary keys of both participating entities are placed into this table. Now, So the first question is, the primary key of works on will be the combination of ESSN and P number. Very obvious, very clear. And ESSN is also mapped or maybe derived from the SSN attribute, right? So ESSN and P number both are individually defined or to be defined as a foreign key also. So in the very first instance, you have to define ESSN as a foreign key. You have to define P number as a foreign key. And the second instance, you have to combine both as a primary key of the works on relation. That's it, right? So now I can see most of the details has been, all of the details which we have drawn in the ER diagram are now mapped into this logical schema, right? So with the same conception, same ideas, same logical steps, you can derive the logical schema of any given ER diagram, right? So there is no additional steps. So primarily we have six steps, right? So first three is for deriving entities, last three are deriving the possible foreign key relations. So now you can correlate the students of CS5, CS4 and CS6. Now you can correlate why we have placed the foreign key on different entities and what is the theoretical background of it, right? So that is for today's discussion. Now, if you have anything to discuss, anything to raise on these steps or in these diagrams, just let me know.